Oh, hello, everyone. We already heard everything about iterators, so I will not have a problem with timing. I have 25 minutes, so yesterday I took a little bit more, but thank you, Michael, so hopefully this time it will work out. My name is Lucas. I'm from Bern. I'm one of the co-organizers of the Go Meetup in Bern. And beside of that, I do some Go freelancing gigs for companies in Switzerland, but also around the globe. And I hope that I can give you an introduction to this new feature we have in Go since 1.23. And I have stickers, so actually they have the Bern flag on it, so they might not be that relevant for you, but if you like to have one of those on your laptop, find me after the talks and I'm happily handing out your some stickers. So what are iterators? We can ask Wikipedia, but I like the ChatGPT answer for a 5-year-old better. Imagine you have a box full of colorful marbles. If you want to look at each marble one by one, you could ask a friend to hand you each marble one at a time. Your friend is like an iterator. So it's, now we are all on the same page about that one. Even before Go 1.23, there are examples in the Go standard libraries where there are iterators. For example, in the bus.io package, but also if you do database queries and you have some rows and yes, you iterate over it, or if you traverse a file system with walk, you get all these entries in the directories and you iterate over those. So what was the situation before Go 1.23? There was no standardized way how to iterate over collections. Also in the standard library, there have been a lot of different patterns, sometimes only subtly different, but still different. Often state tracking leaked to the caller, and the caller needed to do something in order to maintain the state. Also cleanup often leaked to the caller. Again, with the database result sets, you always have to remember to close it after you are done processing it. This is not a good situation. Additionally, with generics, we now have the possibility of generic containers in Go, but without iterators. Come on, doesn't make fun. And we have a lot of situations in the Go standard library where the interface or the API is basically collect and return a slice, which is rather compute intensive. You might collect too much data, and with iterators, this could be improved and made way more efficient. And also, the Go team has become very hesitant in adding more iterators with this bad situation, and a lot of proposals basically have been blocked. So quick refresher, what kind of loops do we have in Go? We have the standard C style loop with initialization condition and incrementation part. We have range for range loops, where we can iterate over arrays, slices, strings, maps, and channels, but only the built-in types are supported, and there is no way to have such a loop with custom containers. And since Go 1.22, we can also iterate over integers, which is basically the same as this C-style for loop. So now let's enter range over func or iterators in Go, as mentioned, landed in Go 1.23. With this new construct, we can basically range over a function. And this sounds extremely weird if you hear this for the first time, but this is actually what happens, and we will dive into how this works under the hood. There are 3 forms supported. Michael already mentioned them, with 0 value, return value, 1 and 2 return values. For the 0 return value, I have never seen an example for that, so I'm not sure if this is even useful, but it's there, you can use it. And as Michael already mentioned, we have this new function definitions in the iter package for seek and seek2. The difference is if we work with one or two return values. Let's actually hide this one here. Okay. So now let's have a look how the control flow works. So we have this very small main function. We have a call to sequence, which is basically like a constructor returning such a iterator function called seek here. Then we have the for loop where we range over this function. And as soon as we see 5, we will break. Otherwise, we print what we got. And this is now the implementation of the iterator itself. We can see we have this signature seek with only one return value. And if we use, or if we execute this code, first we call the constructor, which then returns the function, which is actually the iterator function. And then when the loop is started, this iterator function is called, and it has this endless loop inside of the iterator function, starting from 0. And every value is returned back using the yield function, and this calls actually the loop body. So with the for loop, the iterator function is called. Then we have the endless loop inside of the iterator function. We have this function yield, which returns the control flow back to the loop body. This is how this works under the hood. And whenever yield is called, we get back this Boolean value indicating if the loop should continue or if it needs to break, for example, or end. For example, if there is a break or an early return or even a go-to, which could lead to a situation where the loop needs to be ended. And this function that is used to hand over the control flow to the loop body is called yield, and this is basically a convention put in place by the Go team, and I recommend to stick with that for better readability and maintainability of your code. So let's have a look at some examples. Bigger, I guess. Works like this?
One more.
One more? How can I even type this? Okay, so the first example is exactly the same that we had on the previous slide. We have this main function calling this seek iterator, breaking when we have the value 5, and below we have this sequence iterator, and if we run this, we get the expected result, counting from 1 to 4, and we break as soon as we see the value 5. Nothing fancy here. So let's jump to the next example. First look at the code. Oops. So here we have a slice containing the words 1 to 10. And then we have an iterator that returns these values from the slice in backwards order, and we print the values. And again, we have the iterator implementation below here. It's implemented as a generic iterator, so you can basically pass any slice. And we have the expected for loop starting at length -1. Counting down until we have 0 and yielding the values from the slice. And if we execute that one, no surprise here, we get the expected result, we get the words in backward order. So last but not least, And this is now boring because Michael already showed it. You crashed my talk. You owe me at least a beer. Okay, so we have a map, and Michael already said order is not guaranteed or even randomized in Go if you range over it. And yes, I have this range over the map here, printing the values, the key and the value. And then I have this ordered by key iterator, and I did the implementation myself, but obviously there is now implementations in the Go standard library, and I highly recommend to use those instead of my code, obviously. But I do the same thing. I create a slice with the length of the map. I range over the keys, add them to the slice. I sort the slice, and then I range over the keys in the slice and return the key and the value from the map that is passed. So again, nothing fancy. And if we run this as well, and we increase the size here, we can see at the top the random order from the map, and below, as expected, the ordered output. And if we run this multiple times, you can see in the top section, the order is changing all the time, and below it's stable. So these are 3 use cases for this new package in Go. So now I would like to dive a little bit deeper, something that I think is very interesting in the way how the Go team decided to implement these iterators. And what I found is there are a lot of stages, or you can call it hooks, where you can actually add your own logic if you implement your own iterator. This is not something that is like described by the Go team as far as I know. So I found those myself. So let's jump right into. So what we have is, again, such a constructor function that returns a iterator. And what we can do is we can have a global initialization part for this iterator and also a global cleanup part. And I will show you later what you can do with that. Then we have the iterator that we actually return, and there again we have a section where we can do some setup or preparation code, and we can also have tear down code or cleanup code. And then we start to iterate over the elements, or we have this for loop to loop over the elements we have, and we can do something before each iteration. Then we call the loop body with yield, and we can do something after every iteration. We can also do code that is only executed when we break early with a break or return or go to statement. And we can also have some code that is only executed whenever we exhaust an iterator completely. And this gives a lot of opportunity how we can work or where we can hook into depending on the situation you face. So again, let's have a look at some code, and now it will become really challenging with this resolution. So what I have here is I have an iterator, and I have print statements for all these hooks or stages that I showed you before. Global initialization, global cleanup, then we have setup, tear down, before every iteration, after, before break or cancel of the iterator, when the iterator is completely exhausted. And then also in main, I have more print statements before we even start with the iterator than when we are in the loop body in the continue case, in the loop body in the regular case, in the loop body in a break scenario. And then we, since we break the iterator here, so we have the values, the prime values until 13, but we break after 11. So the iterator is basically not fully exhausted at that point. And we have this print statement between the iterators, and then we continue to iterate over the remaining values with a second call to this iterator, and we have a print statement again. And now let's see how this looks. Oh, that's the wrong one. So let's scroll a little bit up. So first we start main function, then we have the global initialization, then we set up the iterator for the first time. This is when we have the for range statement. Then we are iterating over some values. Then later we have the continue, and we see that we don't have the in loop body statement because we continue before it. Then we go ahead. Then we have the break statement, and we have this again from inside of the iterator that we now saw, okay, there is a break situation. Then we have the first tear down of the iterator when the first loop ended. We are back in main between the two for loops. And then we start the second loop, and again we have set up iterator. We have the iteration itself. We have the end of the iterator when we exhausted all the values. Again, we have the tear down, and we have the global cleanup of the iterator. So we can, with this global, we can really track if the iterator is completely exhausted and only close some resources or do some cleanup stuff whenever we have processed the iterator completely. And this, if I quickly jump back here, so this global part is done using a context. So I pass a context with cancel, and I add to the context this after func. So as soon as the context is then cancelled, this function is basically executed after the whole iterator had been processed. And now another example I would like to share with you, and this is basically the light bulb moment when I really started to enjoy this new iterator feature. One problem that was not unsolved, but it was tedious to do is fan in over an unknown number of channels. Like you have some producers, and every producer returns you a channel where the elements the producer produces are returned, and you have one single fan in function, and you would like to collect all these elements in a single place, and you don't know the number of producers beforehand. And this can be done with iterators now in a very nice way. So what we have here is we have some production lines. We produce trains. This takes long. Then we have cars and bikes. And in main function, we start first the producers, and then we have this function consume with context, and we pass here a channel, a slice of channels. So basically, as a variadic argument, we pass a previously unknown number of channels, and we can then range over this and print every element that is produced. And if we run this code, get it bigger first. So we can see first all the producers are started, and also the consumers are started. Then we get these items, bikes and cars, and at some point we also have the train. Here we go. And then after everything is produced, all the producers are shut down, all the consumers are shut down, and in the end, all is done. Now you say, yeah, but this is just demo, prove it. Okay, I mentioned I have some stickers, so let's produce some stickers. So I just added to the slice of production lines one more item. And again, if I run it, surprise, surprise, some stickers are produced, and after everything is produced, everything is cleanly shut down, and we have a clean sleep again. So now you might say, yeah, but what about if we break early? Yeah, let's do that. So after we have produced 12 stickers, we will stop producing and go home. And as you can see, we have the go for sticker 12, and after that, all the consumers, all the producers are shut down, and the program cleans up everything behind itself. Now, what about if we cancel the context? Yeah, let's look. And again, after bike 6, same thing happens. Here we go. We have bike 6, and we decide to go home early, and all the producers and all the consumers are cleaned up, and everything is nice and pretty. And what is really compelling is for the caller, for the user of this, it's just a for loop providing this function, and we can fan in from an arbitrary number of channels. And this was really the light bulb moment for me, where I think the way iterators have been implemented in Go is really, really nice. So let's go back to the slides. So one more topic, and actually something new that Michael did not touch, so thank you for that. During the proposal process, there was quite some discussion about push versus pull-based iterators, and there are situations where one is more or superior, and other situations where the other is better. All the examples we looked at so far are push-based iterators. Basically, the yield function pushes the value to the loop body. And there are situations where it's better to have a pull-based iterator where the loop body can actually decide, now I need the next value, or now it's time to stop processing that. And the standard library package iter provides two functions, pull and pull2, which converts any iterator to a that is push-based to a pull-based iterator. And here we have some example code, and you can see if we use this function with an iterator, we get as a return value next and stop. Two functions we can then use to work with this iterator. So in order to get the next value, we call next. And in order to signal that we are now done with the processing, we use stop. Now, this example, in this example here, it doesn't really make sense to use a push-based pull-based iterator, but I have another example prepared that shows how this is useful. And this is the function called zip. What zip does normally is if you have two slices, normally equally length, with equal length, you would like to return tuples containing always one value from the first slice and one value from the second slice. So we have two slices here, one containing the words 1 to 10 and one containing the numbers 1 to 10. And what we then do is we use this zip function to return tuples always containing the word and the number. And in that case, you can see it here, we pass we pass push-based iterators as arguments, and then we convert them to pull-based, giving us next and stop functions, and then we start to iterate over those in parallel, always picking a value from both slices and yielding them back or returning them back to the loop body. And one last time we can see this executed. And we get the expected result. We get always the word together with the numeric value. So what is the situation now with Go 1.23? There is now a standardized way to iterate over collections. State tracking can be completely hidden from the caller. Automatic cleanup can be completely hidden from the caller, as we have seen in my channel fan-in example. The foundation is now laid to have custom containers that support iterators. For example, a tree with breadth first or depth first iteration patterns or iterator functions. We can replace collect and return slice APIs now with iterators and having more resource efficient ways to go over this data. And a lot of proposals for the Go standard library are now unblocked, and we already saw the examples in maps and slices packages, but there are many, many more where the proposals sometimes already is implemented for Go 1.24, and in other cases discussion is ongoing, but expect more features to come, and that iterators will be fully embraced also in the Go standard library. That's it. Thank you very much for your attention.